Hi, welcome to my channel about robotics, physics and embedded systems. With this video I go back to my old Arduino Mega2560. Reason for that is ongoing interest in a video that I've made 6 years ago. It was number 37 in the first series of videos that I made on the Arduino, and specifically a simulation using Scilab. In that video I made a simulation with pulse modulation, and that is still being watched today with a viewer count of over 2000 views. Thank you for that, by the way. But the question has been asked, can you do other simulation as well? And I'm going to try that. But for a simulation I don't need hardware, so yes, I connected this Arduino to my computer, but it's not ready for work in this situation, so I go to my computer for the simulation. That means screencast. So this is the screencast that I was referring to, and if you've watched my videos before, then you know that I use Scilab, although there's one difference with the video of 6 years ago, a very different version of Scilab. Looking at the old video, I have tried to set it up exactly the same, although not the values yet, and 1 ohm is not much, so I make it 100 ohms. And this I will make 5 volts. And then there's the question, alright, I used to do it pulse width modulation, and I'm not even 100% sure that I managed to do it. But if you look at the palette, then, well, pulse width modulation is obviously with the width of the pulse. So 1 up and 1 down is 1 period, and the wider the top side, the more pulse, the more signal it is, and the higher the value. Pulse amplitude modulation obviously is the higher it is, so width doesn't matter. And if you look at this, well, the bottom is much wider than the top, so can I put it in any way? I can't really vary the amplitude. I can vary the pulse, so this is absolutely not applicable for pulse amplitude modulation. Can I do it anyway? That's a very different question. I hope so, because otherwise this whole video would be of no use. Well, educating, yes. Useful, doubtful. One solution is to have a sine wave and then alternate it with another sine wave or voltage which has a different amplitude. So I gave this one an amplitude of 2 and this one an amplitude of 1. Combined they give some other thing, but I'm running into a problem. In the old version of Scilab you had a plugin which provided a conversion from this connector to this connector, square versus triangle, towards triangle, which I can't find in this version. So how to accomplish that is a good question. Maybe I have to search any further, because in this configuration it's not going to work. And I have to add it to the signal, but how is a good problem, big problem right now. And by the way, I am not the first one to try to show the possibility of pulse amplitude modulation in Scilab. However, the ones I found don't do it using Xcos, they just program it in the Scilab language, which may give a very nice result, but it's not graphical. And it's nice to have a graphical simulation. I tried another solution. I replaced this block, which was here, obviously with a summation, and two sine waves, one of which is now set to be one amplitude, one frequency, and the other being both 3. Will this be helping? Well, the frequency is much higher, obviously, so there should be something visible. However, I get an error during the parameters update. Changed it into the existing one that I copied from the old video, which gave the same. So now I'm at a loss at the moment why it gives this parameter block update or block parameters update. And basically it's back to 0 to find out or to make a circuit that works, and then building it out to something that I can call maybe pulse amplitude modulation circuit. After a little searching, and you will no doubt have seen this no such file directory, and I do have this file because this is what it is about. This as well, but certainly this one. It's a library which it cannot find, and that is the clue with this problem, because it is there. Scilab is looking in the wrong directory, and I have no clue how to fix that, other than making some symbolic link to it. But otherwise, that is a problem, and it has to be fixed, obviously. So I'm going to try it and then find out how and if this is working anyway. And to give you an idea of the cause of the problem, here it says 11, which doesn't exist. It has to be 12. And there are CRT begin S, this one, and the other one is in another directory, but anyway, they are there. So how is Scilab looking into a non-existing directory and into a wrong directory anyway? Once I have found that out, I can go on. I kind of solved it. In Linux terms, Unix terms, I created a symbolic link to the file that doesn't exist, and that seems to work. And then what is the simulation? At first it seems to be a higher amplitude. So is this actually pulse amplitude modulation? I'm not quite sure, because it is looking like the same but elevated, and that is not quite what amplitude means, because amplitude means also down. So you have something, if you follow the mouse pointer, like this, and then smaller, and then again this. So yes, it has a higher amplitude. It is a summation of two waveforms, but is it actually pulse amplitude modulation? I doubt it. So let's verify the parameters. And the point is, I can't actually set 0 level. Can I set something here? No, not really. So does it look like something with amplitude? Yeah, it does. Because here it has a higher amplitude once every 3 cycles. But I'm not satisfied with this. So what to do? I think for next time dive deeper into it. If you're still watching, thank you for watching the whole video. If you like this video, please do subscribe, like the video, click the bell for notification. You can also follow me via Twitter and Instagram, and you can also support via PayPal, Ko-fi, and by becoming a patron. Please see my website for much more videos. Also my YouTube channel, obviously. And this is going to be continued because I want to solve the pulse amplitude modulation. For now, have a great day, stay safe, take care, bye.